Um, so I'm just going to continue with ER diagrams today. So we did step 1, which was the strong entity rule. So this is how you convert from ER diagrams and how you can generate the tables. So we did the strong entity rules. So what you do is you pick the tables that were strong entities, and then you you list all the simple attributes from the strong entities, and then you choose any one of the candidate keys as a primary key. So we did that for the employee, department, and the project tables. So the next one is the weak entity. And so we only have one weak entity, which is the dependent. So we're going to look at the dependent. So this is going to be step 2. So for the weak entity, you just add the simple attributes, just like you did for the strong entity. So then you include, so this is the one. So remember that in the weak entity dependent, we did not have any primary key. So all we had was, we put down the name as a key, kind of almost arbitrarily, but it didn't really have any unique key. So the only way a dependent could get a key was tying it up with the employee table. So that's what you do, is that in order for the weak entity to have a key, you have to include the table, the attribute from employee table. So include the primary key from the employee table. And so this is where the term foreign key comes in, because it's called a foreign key because it isn't from the dependent entity. So you include the primary key of employee as a foreign key in dependent. And then the primary key of the dependent table would be the primary key of the employee table, which is social security number, plus the name, the dependent name that we had. So those two together would be the primary key. So now we have the dependent table is going to be so if you look out here, we have ESSN, dependent name, sex, birth date, and relationship. So that's how you get all the attributes in there. So we have and then you bring down social security number from the employee table. So that is the weak entity rule. And so with that, we get the dependent table. Okay, so then the next step is so now we got the strong and the weak entities. So now we have to start looking at all those associations that we had. We had several of those. We had the 1:1, the n:1, and the m:(n) relationships. So now we're going to start looking at all those relationships. So that's step 3. So we go into, so first we're going to look at 1:1 relationship. So I'm just going to have to go back to the previous lecture and let's look at the 1:1. This is lecture 30. Okay, so we have, which were the 1:1 relationship we had. Okay, so this was the 1:1 relationship was employee, managers, department. So we have, so we're going to look at this relationship now. That's a 1:1. So this is the managers. Let me just bring it up here because I'll just bring it to the other. Okay, so we're going to look at this relationship. Okay, so we have, okay, so now we have the employee and department. And so the thing with here is that it's 1:1. So they are equal in that regard, but there is one difference between the two. And that is that the employee table, it's a 0:1. So not all the employees participate in this relationship. On the other hand, the department fully participates in it because it has the total participation. So the first thing we do is you select the entity that has uh, total participation, and you'll see why. So that's step 1 is the entity, which is department. So sometimes you might have a 1:1 relationship when neither entity participates in it fully. If that's the case, you can select either one. So, okay, so that's step 1. Then in step 2, so now you have the department table out. So let's just go to the left-hand side. So we have the department table. And now if you look in the department table, we've added the manager social security number and manager start date out there. So what happens is that you pick department. So before I write it down, what you do is that which has total participation, and then you bring down the primary key from the employee table has a foreign key into this department table. And then you pick up the manager start date, which was linked to the relationship. Really, it didn't belong to either entity. So you pick this manager start date and also add it to the department table. So And then finally, you bring down the manager start date. So move. So that's the department. So remember the original department that we had only had D name and D number. So now that's how we add manager social security number and manager start date. So let me just bring this down out here. So we have, and so we add okay, so that's the department table. Once you've added the relationship in the manager's relationship into it. Okay, so that was step 3, which was looking at the 1:1 relationship. So next we're going to look at the 1:n relationship. So before I move to that, I just want to ask you, why do we, in step A out here, why do we pick the entity with total participation? I mean, can you just think of a logical reason for doing that? I mean, why did we not just add D number and manager start date into the employee table? Why is total participation? Why did we pick department?
Would you get lots of nulls?
Yes, that's the right answer. That's really good. You know, that's the reason really. If we picked up employee table, we would have so many null values, and it's a terrible design to have a lot of null values in your database. So that is the reason that you pick department. So if you have design where you have a 1:1 relationship where none of the entities are participating in the relationship totally, so it's a 0:1, 0:1 on both sides, then what you should do is you look at the table and see where the number of null values would be less. So let's suppose that department did not participate in it fully, and we had a 0:1 and 0:1 on both sides. We know that an employee table is very large. In comparison, there are few departments, but there are many employees. So even if department did not participate fully, it's a really good design choice to pick department and not employee. So that was the reason for this total participation. Okay, so now let's look at step 4. So we had step 1, step 2, and step 3. Okay. So now we're going to look at 1:n relationships. So we're going to look at 1:n. It could also be n:1. It doesn't matter. They're both the same. So in this case, again, I'm going to have to bring the old, yesterday's lecture back in. So we have, had department controls project, employee works, no, that's MS2N. I think I missed one from the previous lecture also. Okay, so we have works on, so the MS2N, employee dependent of is a 1:n, and employee supervisors is 1:n. So we have 1, 2, 3. I think I'm missing one. Let me just go to, this is 3029. Works for, yes, that's the 4th relationship. So we really had 4 relationships that were 1:n. So let me just list those down. So we have had employee works for department, and this was an N on this side and a 1 on this side. So that was one. Then we had just okay, the next one we had was department controls project. So we have that was a 1 on the side and N on the side. And then we had, let me move dependent to the last one, supervisor. So we have employee, supervisors, and this is employee on both sides. And it was a 1 on the side and an N on the side. So we had 3, and let me pull this down, the employee dependent one. I'm going to put this in. So we have dependence, and this was a 1:n relationship. So we had 4 1:n relationships. So I'm not going to consider this one, the last one, because we already took care of this 1:n relationship when we dealt with the weak entity rule. So this is really covered on that one, so we don't have to deal with it. So we're going to look at the first 3 relationships. So the rule for this is, so let's put it down. So we have, you start. So since we have so many of these, I'm going to just put down a general kind of case. So we have 2 tables, because the same rule applies everywhere. So let's say we have 2 tables, S and R, and we have, and let this be the one side and let this be the N side. So let's consider these tables. So when you, in step 1, you select the N side entity, which in our case is R, because that's on the other side, the N side. So then what you do is you include S's primary key in R. So and here as a foreign key. So that's step 1. So let's look at the, so we have the employee and the project is on the N side, and we have the employee on the N side. So let me just write. So we have, so this was the employee. So I'll just write it down. We had on employee, we had social number, birth date, address, salary, F name, last name. So now we add the SS primary key. So I'm now looking at this relationship. We have employee works for department. So employees on the N side. So what we have to do is we have to add the department's primary key, which is D number. We have to add it to employee as its foreign key. So I'm going to add D number out here. So that's how you get D number. So okay, so yeah, so So that's how you have D number comes here. And similarly, if you go back out here, now we have employee, supervisors, employee, and this is again a 1:n. So here you just take social security number, which out here we call as a supervisor social security number, and add it there. So that's how you add. That's how you get those two keys in there. Okay, and so the next one is the project. So in project 2, it's on the end side and we have department on that side. So and then we add D number out there. Okay, so that's how you get this one, and we get D number. And if I go down here, this is the controls, works for, no, this managers was a different one, and supervision. What I just want to, this was a weak entity. Okay. Okay, so that's how we have the managers was the 1:1, and then works for, supervision, and controls is the 1:n, and the dependent really goes under the weak entity rules. So that's how we got all of these. So now the only one that we really need to look at is the M:n relationship. So does anyone have any questions so far? Oh, so again, I just want to ask you, so why do you think, what would be the problem out here? I said that we always pick R, the one on the N side, and we add S's primary key to R. Why do you think you do that? I mean, why not add R's primary key in S in this case? Or is it even possible to do that? So the question is, could you add, instead of adding department number in employee, could you add social security number in department in this case when you have works for? So can you give me the logical reasoning out here?
Is this time is redundant?
What's that?
Like, would it be redundant since you would have to have every single SSN so you just basically be copying that?
Yeah, it's also not so much, you will get the thing like either you're going to get redundancy or you're going to have multiple values, right? Because you have you could have 100 employees working in departments. So either you put redundancy in the department table, keep repeating the same information, or you have to have a multi-valued attribute. So in which case you're not in first normal form. So you're right. So that's the reason. So that we always, I mean, so in this 1:n rule, you really don't have much of a choice. You really want to put it in the N side, because if you put it in the R on this side, then what's going to happen is that either you have redundancy or you have a table which is not in first normal form. Okay, so that leaves us with the very last one, which is the works on MS-to-N relationship. So we have, or almost last. So okay, so we're going to look at the M:n relationship, which is the works on relationship. So in this case, now very much now that you look at the table out here, you can see that you really have a separate table called works on, in which you have you know you have SSN. So you have the primary key of employee here as a foreign key. You have the primary key of project out here has a foreign key, and then you have ours. So, it's kind of straightforward. Let me just write this down. So what you do is you create a new table. When you have an MS to N relationship, you have to create a new table. So we created this new table called works on. Then you add the so you add them as foreign keys. So so the key and the key of works on is going to be SSN and P number. So 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 the foreign keys together, when you have MS to N relationship, you take the primary keys of the tables on either side, and then the table of works on will be the combination of the primary keys of the other two tables. So that's the primary key. And last, you add ours. Okay, so that's how you get this table. ESSN P number. So we have I shall just call it SSN. Okay, so now let's look at this diagram on the left. And if you look, we've covered a lot of the tables. So the only thing that's left is this one last table called department locations. So how come department locations got left out? So let's just go back to this diagram out here. So if you look at department locations is a multi-valued attribute. And if you look at the very strong entity rule, we always started with either simple attributes or composite attributes. We never really looked at multi-valued attributes. So that's the last thing we are going to look at. The last step is, what do we do with multi-valued attributes? So that's step 6. So it's multi-valued attributes. So as you can see from the left-hand side, it's a completely different table. So that's what you do with multi-valued attributes, is you create a new table. So step A is you create a new relation R dash for each So if you have several multi-valued attributes, and each of those gets their own tables. And then what you do is you add the primary key of the table from which you pick. So in this case, it was department. So you add that to this new table R dash. So it's a foreign key. And then, so what's the primary key of, so primary key of R or R dash would be this attribute that you brought in, and then the original table R dash. So it's together, that's the primary key. So that's how you get the department locations. You have D number and D location, and they both together are the key. So that's how we get the whole table. So that's it. So that's the algorithm for converting from an ER diagram to the tables. So does anyone have any questions, or do you think you understood this? So it is actually not, I mean, this is a rather simple table, simple ER diagram. Plus, we've been looking at the company database for a while, so you're all really familiar with it. So it is not too hard. You can have pretty complex ER diagrams that connect up, but even then, the algorithm is pretty straightforward. So even really complex diagrams, as long as you follow the rules, you can convert into tables quite, just follow the rule blindly and you can convert it down. So, I mean, that's the last assignment will be on ER diagrams, and, and you can take a look at those diagrams and see, and maybe practice on how to convert it down. So one of the things is that, remember, we did normalization just before we did this topic. So the question is, when normalization was part of design, so where does normalization come in? So normalization really comes in after this step. So initially you start with the ER diagrams, and from the ER diagrams, you convert it into the first set of tables. But the next step is that you have to figure out that you'll have to kind of look at the original set of tables out here, and then say, okay, are there any normalizations in here? I mean, do I have to further divide? So let me give you an example. So suppose in our employee table, so this is the employee table, and suppose when you are talking to the company employees, you realize that, you know what, if you know the supervisor's social security number, then you can determine the D number. So essentially what they're saying is that a supervisor um, always, I mean, all the employees that are supervised by a supervisor, they're all in the same department, which is the supervisor's department. So essentially what happens is that you when you talk, you find that this functional dependency, there is a functional dependency that says supervisor social security number determines D number. So then you look and say, okay, so I have this dependency in this table. So if that's the case, it's, it's supervisor social security number is not a key, nor is D number. So I mean, so this table is not in Boyce Codd normal form, so you need to divide it further. So in this case, so you will divide. So you should divide it. So we do, let's say, R1 dash. And then you have the remaining. Six, and then what else do I have? Salary 6. I think I've got everything in there. And then you put down supervisor social security number. So you remove D number from the employee table, and so that's what you would do. So that's how so that's how normalization fits into the whole design principle. So does anyone have any questions? Let me just bring this. Okay, so let's do kind of a simple example and see whether you can convert it into tables. So I'm going to do an ER diagram. I'll do something rather simple. So let's do an example. Okay, so I'm going to have to draw this this ER diagram. So we have, it's kind of a, drawing these diagrams, it's not particularly easy. So I'll try not to make the diagram too messy. So really what I want, I'll draw the diagram, and the purpose is that, just see if you can convert from the diagram into tables. Okay, so we have between faculty and course entities, we have the teachers relationship, and it's 2:4. No, 1:1 on this side. And faculty, actually, and then you have a 0:M out here, and 0:N out here. And then we have users. So how many, has anyone finished and would like to just tell me how many tables you got? mean, there is a strong entities are faculty, book, and course. So those are 3 tables right there. And then we have the weak entities section. So that's 4. But then we have all these relationships, which are, we have an MS to N, we have, so this, oh, sorry. So we have this one's an MS to N relationship. So let me just, so this is, and this one would be a 1:4 relationship. So it's a 1:N. Then this one is again a 1:N relationship. And this one would be N:2M. So M:2N, or shall we just write it down as, so this would be 5. Okay, so maybe in the next class, since it's almost time, I would like you just try this out before, I mean, I'll finish off this example in class next time, but just try it out. It is, it's not, oh, I mean, it's a simple example. It's not too simple. The simplest is if I just put down 2, if I just gave you this much, that's a really easy one. But, so it's not, I mean, it's like something I could give in a quiz. It's simple enough. So it's 10 o'clock. So I'm going to see you tomorrow anyway, because tomorrow is, so we have Monday, Tuesday, Wednesday. It's kind of weird.